Hello, this is Xfixium and welcome to how to make a Master System game using Devkit SMS tutorial number 5. In this lesson we write code in the define source file, going over what preprocessor directives are and how to use them. We will also go over creating C macros as constants and how they relate to the game. Let's get into it. Okay, so we're going to start with our defines header file for our source, and one of the first ones we'll be using in the game for our defines is direction types. Now, how we're going to use this in the game is wherever there's a direction that's associated with a number, so direction right is associated with 0, direction down 1, 2, 3, and so on and so forth. We'll use this within our code, and what will happen is this is a preprocessor declaration here with this hashtag. What will happen is anytime this is used throughout our code, it'll be replaced with the value that's associated with it. So when we use it later in code, when it goes to compile that code, the preprocessing, it will take whatever that we had as a human readable numeric, so in this case direction right is actually 0, it will actually replace this syntax with the value that we want to have associated with that. So that's how these defines are being used. At this point they're basically constants, and the other thing about this is that it's flexible, so if we add more types or if we change the value of the type that already exists, we don't have to change it throughout the entirety of the code. We can just change it in one place. So like if down magically for whatever reason I decide that I don't want it as 1, I want it as 4, I don't have to go through all of my code and change all those 1s to 4s. I can just change it once, and then anything that already uses this define will change with it. So that's the idea behind it, is that you have these constants that are human readable, so we also know what, instead of just having a 0 somewhere, that we actually know what that value represents. So it's a human readable syntax that we can use within our code, so as constants at this point. So the first thing is direction. So you have right, down, left, up, which isn't anything mind-boggling. I have this set up the way that it is, as we'll see later in code, that when ghosts have tiles that they can select from, 3 tiles at an intersection, if there are tiles that have the exact same distance to a target, like player 1 or player 2, it'll favor up and left, down, and then right as the last choice. So it goes in that order. So if up and left have the exact same distance to, say, the player, it'll favor up first over left and that sort of thing. You'll see that in code. It goes off of this document that's out there. It's called the Pac-Man dossier, which goes over every little bit of Pac-Man that you could ever imagine. So it goes over the behaviors, all the game logic, basically, when it comes down to. So this entire game is based off of this. To a point, I didn't go down to every single detail. I could if I wanted to, but for the purposes of this tutorial, I only took it so far, with the major rules being the ones that I really focused on. So, but it goes over all the details about the ghost behavior. It goes down to the scatter and chase behavior, and Miss Pac-Man is a little different. The scatter and chase behavior, as we'll go through later, is done less than it is in Pac-Man, and plus there's some more random variables in Miss Pac-Man. Miss Pac-Man is essentially a mod of the original Pac-Man, so it uses the original engine of Pac-Man, but then it adds a whole bunch of new things to Pac-Man, as in new stages, and the fruit can move across the board now instead of being in a stack location, and some other random elements that we'll get into as we're programming the game. So right, down, left, all that stuff. I have one that's all. This is used as an index for. I have a small array that has 5 elements in it, and each one of those elements represent a place that a ghost could potentially move into. So when they get into an intersection, there's so many available places to go from the intersection. So again, it uses these directions to see which way is available. So the array is basically just a boolean, so it's either 0 1 0, you can move in that tile or that direction, or 1 0, you can't move in that direction, 1 you can. And then there's another one that's beyond just the 4 directions. There's one more element, a 5th element, where it adds all those directions up together into the 5th one. So directional just means that we're adding up all these 1s and 0s, and that'll hold our value there. And the reason why we want to do that is we add up all the directions. If it comes out to just that you can only move in one direction, then that will basically say in our conditioning that we don't really need to do any of the distance checking, since we can only move one direction. We're just going to continue moving in that one direction. So that's why this is here. So this will be an index for that 5 element array. Direction none is one I added on there for when there's auto scrolling, and this is only comes into play when you're in team player mode, where one of the other players, either it's player 1 or player 2, they might be off screen, so we need to scroll to where they are, either to the top of the screen or to the bottom, depending on where they are off screen. And that's what this, when they're not off screen, so when they're within view, we're going to tell the auto scroller that there is no direction that it needs to go because the player was within view the entire time. So, and we'll use those later, and you'll see where we use all these throughout the game. Game modes, there's only 3. There's a 1 player, 2 player, which is alternate mode, so 1 player goes and then 2 player goes, and off and on when they lose a life. And then there's team play, where both player 1 and 2 play at the same time. There's visibility types, so for all the entities that can move around the screen, if they're off screen, they'll have a marker that shows where they are horizontally on the screen at the bottom or the top. So depending on where, if there's 3 different types. Basically, they're in view, they're out of view at the top, or they're out of view at the bottom, and that's what we're keeping track of here. And then we'll change their sprites based off of that information. Game states. This is the primary state of the game. None means basically we're initializing the game for the first time. We have the title screen that we go to. Then we have the stage where all the actual game play is ran. And then we have 3 cutscenes that are part of that. There is another one that we should have here, which is the demo or the attract mode, but that is not in this game. Next one we have indexes. So we're going to have an array for any entity that's in the game or on the screen, or could potentially be on the screen. So, we have Blinky, Pinky, Inky, and Sue, which are the ghosts. Then we have the bonus that could pop in. We have player 1 and player 2, whether on team play or not. And then we have a miscellaneous index for the last entity that can be on the screen. So there can be a maximum amount of 8 entities on the screen at any given time. So that's 0 to 7. That's 8 entities altogether. Sometimes we use this index for auto scroll just to say there's code when the screen scrolls vertically. we want to know what is causing the vertical scroll. Is it a player? Is it just an auto scroll? Like, for instance, when the stage first starts, it's at the top, it shows a score, and it slowly scrolls down to the bottom screen. We want to know that. We also want to know if nothing's scrolling the screen at any given time. So that's what these values are. Here are the heads up item indexes. So since the bonus items are left to right when we go to display them, banana is the most leftmost bonus item at the bottom of the HUD that we can see. So that is the first one, and then pear, and then we work our way from left to right. Apple, pretzel, orange, until we get to cherry. So these are the HUD items that we can put in these 12. There are 12 slots, like I had described in one of the earlier videos. So when we go to the tile map and let's look at main here. There are slots at the bottom here that they can be any of these bonus items or HUD items can go into, as well as Miss Pac-Man, player 1 or player 2. Player 1 will have the standard graphics, and player 2 would have the blue colored Miss Pac-Man. And so each one of these slots here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When we select them as 16 by 16 pixel blocks, can have any one of those items that we haven't defined. So we can actually put them in any order if we really wanted to, but basically, or essentially, we're just going to follow the original. So again, here's the banana, and then we're going to keep working ourselves right, and that's where we are defining each one of these in that numeric order. So, and we'll see that come into play later. Some of the stuff you want to have some sort of strategy with. So when you go to run showing items in a loop or that sort of thing, you can have some offsets that make sense versus the for loop and the indexer that you have to run through. So that's why I have this in a certain order. And then here we go with the other potential slot items. So it can either be Miss Pac-Man player 1 or 2, or it can be empty. And those are all the choices you have there. So yeah, these are the indexes. So this is how it would look like when we go to the slot array or the item array. So that's why they're numbered this way. And again, we'll see more of that when we move on to the actual HUD source code. Next is the entity type. So any one of these 8 entities within the array, they can be swapped out with other things, different entities. So you have an empty entity that means it's basically nothing, hasn't been set at that point. But then you can have it that these entities can be any one of these types. Most of the time it doesn't matter for these primary ones, which are player and the ghosts, but it will matter more when it comes to the actual bonus item when it goes on the screen. We really want to know what that entity type is so we can award the correct points to whoever consumed the bonus, which could be player 1 or 2. And Pac-Man, that's primarily for cutscenes. Here we have point indexes, or the types that of points that we could have. So any kind of point that's accrued in the game is represented here. So 10, 50, 100, 200, 400. And you'll see that more in action when we get to the HUD. The way that we represent the points is going to be within an array that will be offset when we actually show it up on the screen. audio tracks. This is all the audio tracks in the game. Again, we represent it with a number, but it's human readable. We'll see that when we get to the audio header file and what these tracks mean. So it's basically all the tracks the game can play. And this is defines for sound effects. Again, give a numeric value here. Also like to give a shout out to Slogra, who made tracks for this game, and Enrico Palazzo, who also made tracks and sound effects for this game. So without their help and expertise, I wouldn't have any audio for this, and audio for a game like this is very important. These are state types, so whatever state that an entity can be in. So player can be moving, it could be idle, it could be dying, unfortunately. It could be dead. And then with the ghosts, they reuse some of these states, and there's quite the ghosts are more complex than really the player states. So the ghosts, I have it that it's at least a little bit strategic here, that the states at the end, like points, house, chomped, entering, leaving, these states here that the ghosts can be. So points is when they get chomped, and then their point representation sprite shows for about a second before they run back to the ghost house. These states towards the end, the points being in the house, or going towards the house, I should say. Chomped, entering, leaving. Oh yeah, house. So the house being in the house. Chomped is when they're in that state where they're running back to the house, and then entering and leaving the ghost house. All these states, what they have in common is that there's no collision detection for them. So I have them at the end so that I can have a simple condition where if I check the ghost entity state, if it's greater than the frightened state, then I don't bother checking for collision detection, because there's no collision detection at this point with these states, whereas the other ones, for the most part, they have collision. Okay, and we're going to move on. I have some tile and indexes, and we're going to use them in our logic. Again, these can change if say my design for this stage 1 changes and I have more tiles that I want in front of the solid tiles, then I'm going to want to change where I'm looking for solid tiles. So currently, if I go into the IDs, I can see that anything after 340 is a solid tile here. So when I put that in here, I put that solid tile 340 in here. What I'm going to do condition wise is I'm going to see if that entity can move. I'm going to check if the entity can move in a certain tile, and if that tile ID on that tile is greater than 340, well then I know it's a solid. So I'm going to use this for conditioning purposes. This also, when a ghost is over a tunnel tile like we discussed previously, so that's 307 when we look on here. So 307 is that tile that we have here where the tunnel is, where the ghost would slow down. So that we're looking for that tile, and then instead of putting a hard-coded value of 307 on the check, I could just change it here if that happens to be if there happens to be some sort of design change. So I can change it here. And the last thing that we need to add to this defined source code are timings. Primarily, there are two formats that we really care about here, and that's the NTSC format and the PAL broadcasting format. Without going into a whole heck of a lot of detail about these, two formats and the differences between them. All we care about is that we were able to provide the same experience between both formats, as in the timings, the speed of which the game performs from one version to the other. Define them here. So here is a list of all the timings that I use in the game primarily. What this pre-processing or pre-compilation directive is saying is, if we define time NTSC, then we're going to use these values for our timing. Else, we're going to use these values for our timing. And these ones here are the PAL entries. They look exactly the same as the NTSC because I never defined them. That's something I'm going to do in the future. So those are the PAL values that we will have to adjust at some point in time. And these are the NTSC values. So if I don't define this, it will compile for PAL. If I do define this, it will compile for NTSC. So that's how this is working. I believe that's everything for this source file. Next one we'll go over is most likely the globals source. So thank you for watching. Until next time.